So that's done. Just one last reminder, if you're not presenting, or sorry, not asking a question or speaking, please keep your video and mic muted. Tim's going to get into what's the deal with fractions in just a moment. If we're going to do the discussion near the end, and then after the discussion, please stick around. Corey is going to say a few words to close off the conference. So Tim, feel free to take it away.
Thank you. I'm Tim Sibbald. I'm an associate professor at the Schulich School of Education at Nipissing University in North Bay. And I recognize a number of names. I've been to the OCMA conference a number of times, and it's good to see familiar names and recognize a few people. I also happen to be the editor of the OCMA Gazette, and if you ever think of publishing an article, or you're interested in doing a book review and maybe you want a free copy of the book, you might want to get me with my editor hat on and follow up on that side of things. We don't hear as much from the college crowd as I think high school teachers in particular should. And I'd encourage you to think about that side of things. Anyway, for today, we're here to talk about fractions, and there's a lot to talk about. It's an area that has received a lot of attention, but it's also an area that's got fairly fundamental challenges, as we'll see. There we go. So in the session description, and this actually is here more to remind myself what I'm speaking about, but I mentioned that this came out of an issue that was raised at last year's conference. And during a session I was doing last year, there was discussion around fractions and a little bit of back and forth, but of course, it wasn't the focus of the presentation. And so the purpose of this session is to create that space to actually have some proper thought about the topic and some discussion. So what we'll do with this, as far as the Zoom side goes, I do monitor the chat to the extent it's feasible while talking. So you're welcome to ask questions through the chat, and I may address them along the way. Otherwise, Derek's going to sort of keep an eye if stuff gets scrolls past what I can see in the chat. And there will be some discussion time at the end. So one way or the other, we'll figure this out. What we're going to do in terms of the presentation is identify some issues, and there's quite a few of them. Set up some context for what's going on with learners, and talk around some of the changes that have taken place, particularly curriculum changes in kindergarten to 8, which took place in 2020, and grade 9 got changed in 2021. We're going to talk around some of the research that's out there, and finally round it out with things we might take away from this for colleges. And that's where we're going to sort of go from a presentation into discussion, because you're the experts about college, and I'm sure you have insights beyond what I will present. So the first thing I want to address is why there's a degree of reluctance to talk about fractions. And you know, there are people who will readily talk about fractions, and Derek and I had a little bit of an exchange earlier, and you know, we're comfortable to talk about it. But in many situations, I feel like this guy where, yeah, I'm the bullseye, and if there's mudslinging to be done, I'm making myself into a target. Uh, it's an awkward topic, especially with the public, where there's a wide recognition that there are issues. The school system usually gets blamed, and there's a claim that things were better years ago than they are today. And examples are often given that seem to defy logic. What generally comes across in these kinds of things is that the claims are polarized. There's no middle ground on offer. It's like it's been percolating so long without discussion that the person has migrated either to the one side or the other. And people who are convinced that fractions have problems are hard to convince otherwise. And people who think that everybody gets fractions are equally hard to convince otherwise. You don't come across them so often, but when you do, there's a general interpretation that the consequences of having weak fraction skills are dire. And whether that's the case or not, I think there are details there. If I was to poll everybody and say, when was the last time you actually used a fraction in your day-to-day life, the responses would vary a lot. And if I said to you, if you didn't know your fractions, would it be dire, or are there compensation strategies? In many cases, there are ways around it. And there are arguable points about whether or not you need to understand fractions, say, to read the fractions on cup measures. Identifying which cups you use doesn't mean you understand the fractions. It means you can take the symbolic writing that's on there and equate it with the recipe. It doesn't mean that you understand whether a third is more or less than a half. It just means you can understand the writing that is on the cup. So I think there's a depth of understanding there that challenges us a little. I find that in conversations, the role of things like calculators serves to muddy the waters. And many times in general conversations with people, particularly in public, they'll introduce these things without really realizing what they're doing. For instance, when a cashier runs into problems, people will say, well, they have a cash register, and they don't necessarily appreciate what a cash register does or why the person's confused, this sort of thing. They just add it in as additional information without really parsing it out. Oftentimes, solutions are deemed to be silver bullet solutions. They'll fix everything. And quite often, they're ridiculous solutions. And I want to specifically state that with these two, there is no way that getting rid of phys ed is beneficial to teaching fractions. And there is no way that we should be getting rid of all elementary teachers and installing a whole bunch of math experts. That would do too much damage to other things. But these are statements that have been made to me as solutions to the fractions problem. I think they're ridiculous, and I will say that on the public record, but they have actually been suggested to me. So as far as the issues go, it's clear from last year's OCMA meeting that there are a lot of students recognized as struggling with fractions. This is borne out in the data about it. Research says this is the case. My own research says this is the case. But when you dig into that and you say, why are they struggling? It gets a little more complicated. Sometimes it's about algorithms. Other times it's about details, accuracy, as opposed to approximating, or how to do things, what order. Generally, that leads to people knowing that they have issues with fractions, and that leads to a reluctance to use them. And a reluctance to use them simply reinforces the problem, because then they're not exercising the skills, and one thing leads to another, and basically they end up sidelining it. And if they sideline it, then it's unsupported. It's not that it necessarily gets worse, but it definitely hinders their confidence. With calculators, even if you work with a fraction, you get a decimal out, unless you are one of the rare people who uses fraction mode. And students who have calculators with fraction mode very, very rarely actually know how to use it. And it's rare that they do use it. It may be there, but if they're not using it, then why aren't they? And I think for teachers, oftentimes there's a bit of a struggle there of, do you want to create a reliance on the calculator? Or is the calculator a stepping stone? And it's generally viewed that it will create a reliance as opposed to being a stepping stone. We do know that fractions are very important in some careers. In construction, the use of a tape measure is a fundamental skill, and it is based on fractions. Nursing, it's well established that fractions are very important, particularly in pediatrics. And there are classic examples, unfortunately, true scenarios where fraction issues led to serious consequences for patients. And in pediatrics, that is particularly concerning. I remember reading years ago a true account where a pediatric situation ended up putting a baby on life support. And it was because the medication was handled incorrectly due to a fraction mix-up. The child survived, but the fact that it can put a person on life support speaks to the importance of it. In terms of context, and we need the context in order to separate out some of the pieces. Society at large is quite distinct from us, and any issues with fractions in society at large are going to outlast us, because even if we were to fix all the fraction problems in education tomorrow, it would take another 30, 40, 50 years to get out into society. The bashing math in public is not going to go away anytime soon. In kindergarten to grade 8, elementary schools, we've had a change in the curriculum. That's now underway, and we'll talk a little bit about that. High school transforms fraction teaching. So there is the change in the grade 9 curriculum, but there's also what the handling is in courses after that. And I think it surprises a lot of people to find out that, yes, imperial measures are in the high school curriculum. They're just not in the university stream explicitly. They occur in the college stream and they occur in the locally developed grade 9 and 10 courses, which then feed into the essential 11 and 12. We've got the college piece, which is your focus. And then we have the workplace and daily life. And the workplace in particular is a consequence that is very relevant to your teaching. I have the MPT mentioned on here. This is the math proficiency test, which was put into place 2 years ago, 3 years ago. So all new teachers, in order to get their professional designation, have to do a math test. This was instigated. And so I've put it in there because it potentially speaks to changes coming in the school system as a result of that requirement. So I'll speak to it briefly along the way. And those are the major players in our education context. With the 2020 curriculum, which changed the curriculum for grades, actually that should be grades 1 to 8. It did not change kindergarten. For grades 1 to 8, fractions have been relatively stable over the years. It has not made huge changes. But in the first strand in that diagram, you'll notice a red divide sign on the left-hand side. And under number sense, rational and irrational numbers, fractions, decimals, and percent. That is where fractions reside in kindergarten to grade 8. And I wanted to include that diagram because those are all of the topics that are taught. It is one topic among many. Clearly, it would require a lot of instruction. But to give you a sense that, yes, it's one topic among many, it represents a relatively, it's one bullet among how many bullets? There's quite a few bullets there. So what happens is that in grades 1 to 3, it's all small denominators. It's getting at the meaning of a fraction. It is getting at the notion of equivalent fractions. And the meaning is complicated by the fact that you have the part-whole model. So a third of, well, say a quarter of a dollar is 25 cents. That notion that it's part of. So if you break a chocolate bar into half, 2 halves, the half is a half of the whole. That is the part-whole definition of a fraction. That dominates grades 1 to 3. Another meaning of a fraction is the notion of part of a set or a group. And so if you have a dozen eggs and perhaps you take 3 of those eggs, you're taking 3 whole items from a group of 12 items. That's not quite the same thing. Now, you can convert them and you can say, well, that's 3/12 of a dozen, which is changing the unit. But where the second definition does differ is if you have a pair of items that are distinct. So, here are 2 items. So this represents half of them. This represents half of them. Well, they're completely different kinds of items. And so to speak about one item out of the collection, it's as if you open a curiosity box and you count how many things are in there and you take a few of them. And the difference here is that they don't all have to be the same. So in terms of things like probability, suddenly, the deck of cards, you don't have to argue about whether or not all cards are the same or whether they're different by virtue of the color or the suit. So there's a little bit of a distinction that's there, and it is a little bit confusing. And if you haven't taken time to really think about the nuances of that, it's worth revisiting, because it's an area where a lot of student confusion arises even later on. Grades 4 to 6 deal with denominators up to 12. And so you're getting into denominators where you can have equivalent fractions arise naturally. And you get into basic operations, addition and subtraction. And this starts with denominators that are the same, and it migrates to denominators that are different. The numbers are all small, 12 or less. So you're not dealing with weird fractions like 3/17. In grade 7 and 8, there's a consolidation of skills, and there's a mixing of fractions, decimals, and percents. Ratios are in there. Rates get mentioned. Addition and subtraction gets routinized ideally, and it becomes more generalized. Multiplication and division of fractions is introduced. The concept of proportionality is introduced. Now, I mention this because one of the biggest changes we've had in the curriculum over the years is where multiplication and division of fractions occurs. So prior to 1998, around 1998, multiplication division of fractions was in grade 7 and 8. Actually, it might be 2003. Anyway, around the early 2000s, it got chopped out of grade 7. So multiplication division of fractions only appeared in grade 8. The change in 2020 has put it back into grade 7. So this is one of those little distinctions. It's not going to make a night and day difference to you, but it's an important difference, because when it got changed around the early 2000s, I was teaching grade 9 and I was oblivious to it, because that curriculum change, it wasn't something that was really center stage for me. So much as I was teaching grade 9, I wasn't tuned into the fact that those changes between 7 and 8 would have implications for me. This is now something I emphasize with my prospective teachers that I deal with and point out this issue. So that's the kindergarten to grade 8 piece. And I see a comment, yes, Camille has remarked on the prime numbers, and no accident that I chose 3/17 with a prime number in the denominator. Yes, that's causing everybody to be on the wrong path. It is definitely a challenge. I'm going to keep going, and I'll read your comment later, Tara. So in grade 9, the new curriculum includes fraction skills. The old curriculum did not have explicit fraction skills. And in fact, for the last 15 years or so, the curriculum in high school has not included explicit fraction skills. That may be a surprise to you. It was a surprise to me when I was pursuing my master's and realized this and thought, I wonder what happens to fraction skills when students go into high school, because it's not there explicitly in the curriculum. What happens from grade 9 to 10 to 11? So curriculum-wise, it becomes implicit. The implication is there that they're important, but the teachers tend to emphasize improper fractions, and they tend to have them as, say, coefficients of equations. And oftentimes there are ways to avoid explicit fraction thinking. So, for example, in the 2/3 to the with an exponent of 4, you can think of this as 2 with an exponent of 4 divided by 3 with an exponent of 4. So you're no longer multiplying 2/3 times 2/3 times 2/3 times 2/3. You're just defining what the numerator denominator are. 2 to the 4th is 16, 3 to the 4th is 81. That's 27 81s. I didn't do any fractions. I didn't do 2/3 times 2/3, get a fraction answer. Similarly, 3/4 x equals 15. Well, you can divide both sides by 3/4 and use fraction skills, or you can multiply both sides by 4 and then divide by 3, where conveniently 15 divides by 3. And so you can avoid dividing by a fraction. So that implicit piece of fractions in high school was a specific concern to me on a research front through my master's, and we'll go there. But I want you to appreciate that this means that mixed fractions typically are not being talked about. They are by some teachers, but for prospective construction students, it's not there. It is done in the locally developed essentials, but they wouldn't normally go on to college. As far as society goes, I want to just recount one little story, and this comes from CBC. And this just happened across my radar a little while ago, but there's no end to these sorts of stories. So A&W made a 1/3 of a pound burger to compete with the 1/4 pounder that McDonald's has. And what they found was that it performed better in taste tests. So people preferred it, but their sales didn't take off. And when they did focus groups to investigate why the 1/3 of a pound burger didn't do as well as the 1/4 pounder, it was because the general public thought that a 1/3 of a pound was less than a 1/4 pound. And so they perceived themselves as getting ripped off. I'm not going to share any other society stories, but these things arise, and there's no end of issues. And this is just one example among many. I want to present an example of teacher preparation. So this is, these are students who have an undergraduate university degree, and they are training to be teachers. And what we have here is that on the left side is how they responded to 2x minus 3 equals 7. And across the top is how they responded to 2x plus 1/4 equals 10. And if we look at the number of correct, what we have for the 2x minus 3 equals 7 is 398 out of 469. That's a lot. It's not perfect, but it's a lot. For the 2x plus a quarter equals 10, we have 141 out of 469. It is substantially less. It's not a little bit less, it is substantially less. And similarly, if you look at the number who left them blank, 40 versus 110, these are presumably people who didn't even have a way to start. These are potential teachers. So the issue here is the quarter being in question, where it is mixing a fraction into there. And that fraction is very likely the explanation for the difference. It could be that the subtraction comes in, but that should be small potatoes. It's much, much more likely that it is due to the quarter. It's this kind of research that has pointed to issues with prospective teachers. It has highlights the issue where it's felt that teachers in elementary schools struggle to teach fractions in the first place because of their own knowledge base. And so if there's an issue with the competence of those teachers to handle teaching fractions, then potentially that's something that could be addressed. And that is where the math proficiency test is coming from. It is an effort by the government to insist on a minimal level of competence in mathematics by all prospective teachers. It's in a funny position because it is after they complete teacher preparation and before they join the profession. But the point is that the government is targeting that group of teachers to address the problem. It has unfortunate consequences. It has issues around creating anxiety. You may say, hey, that's fair dibs, because if you question your competence, you shouldn't be doing this. The problem, a much more fundamental problem, is that if we were to separate the world and take a group of people who have problems with fractions and a group of people who don't have problems with fractions, we don't know what else correlates with that. We don't know what else might be happening. It may be that people who are good at fractions are really poor at something else. So we don't actually know. There are other issues around this test. I won't bother going into details, but it's run into trouble with the pandemic. It potentially interferes with the start of careers of teachers. It ignores the fact that teachers do learn on the job, and there are challenges with this. It's a blunt instrument for a fairly specific problem. I'm going to shift over to the research side at this point. And what I want to do with this is just say, here's some of the general research that's out there that has implications for fractions. It's not necessarily solving the practical problems, but it is speaking to that arena. So an instrument has come out last year that concluded that it is possible to measure and separate procedural and conceptual details. So a student makes an error while doing a fraction calculation, that's procedural. But if they have a fundamental misunderstanding of the fractions, that would be conceptual. And so if you can separate those two, potentially research can dig into the kind of issues that are falling in the procedural camp and those that are falling in the conceptual camp, and maybe we can make some progress. There is issue around the use of the form that fractions are expressed in. A decimal potentially is expressing a fraction. A percent is presenting a fraction. But we know that the numerator denominator and the thin line in between, we know that that thing causes an issue. Decimals do not have that issue. One of the problems, by the way, is that thin line, have you ever given it a name? So if you write 3 with a slash that way over 5, when the slash runs on the diagonal, that's called a solidus. When it's horizontal, so 3 in the numerator and a horizontal line and 5 in the denominator, that is known as a vinculum. A vinculum, vinculum. And I have argued in my pre-service classes that one of the hidden issues is that language isn't given to it. So we expect students to see 3 over 5, and over ignores the proper term, but we expect them to see that 3 over 5 as a single number. And yet we have distinct language, numerator, denominator. Well, that makes them different, doesn't it? And so there's an element of conceptual confusion right there around the language of them. It is trivia. You will have to check whether it is Latin or Greek. I don't know off the top of my head. There has been a lot more research around trajectories and the progression of learning that goes on, and whether, do you have to learn proper fractions before you learn improper? Do you need to understand proper fractions before you get into mixed fractions? There are lots of issues around that you can imagine, and there's been a lot of work around that. The largest area of research is for prospective teachers. That is the #1 area of research. And unfortunately, it runs into systemic issues where the courses, if you plan a course for pre-service teachers, you find that there's a timing issue. I could invest an entire course in teaching fractions. I don't have the time to, because I've got to cover everything else. I do find, though, that with students, there is, for the students I teach, which tend to be intermediate and senior, there is a high level of competence. It just sometimes needs dusting off, if you will. There's been a lot of examination of confidence. It's been found that people can control their own assessment of whether or not they can do particular questions. The use of counterintuitive fractions has come up. And when I mentioned 3/17 earlier, that would be a red flag to a lot of people for the inhibition. 17 is a weird denominator. Better watch out for this one. So that kind of research is going on. What you don't see here is anything that's going to immediately lead to solving the world's fraction problems. But I did want to highlight that there is a lot of fundamental research going on. In high school, let's talk about performance. Let's get the rubber to hit the road. These come from different research papers, and I have no reason to think that the numbers have changed substantially over the years. In fact, I have reason to think that the numbers are relatively static. In 2001, a pharmacy entrance exam, 25% failed, 25% under 70%. In 1998, the NAEP is a national assessment of mathematics done in the US. The statistics for this are very, very large samples. So at the grade 4 level, 48% competence. At the grade 8 level, 64% competence. This compares to a 1996 figure that said at the grade 12 level, there was 60% mastery of simple fractions. Simple fractions sort of suggests it's not the full realm of fractions. 1995, you had an assessment at grade 8 of 35%, 36%. So compare that to the 98, 64%. So that's a mixed fraction question, specifically in 1995, 3 1/3 minus 3 1/4. So the difference here may be that the overall emphasizes proper fractions. And so this is one of the challenges of these sorts of statistics. It doesn't parse out the specific kinds of fraction. 1987, identify a number between 6 and 6.1. 38% were successful, 49% said you can't do that. And I'll mention this 1976, a half plus a third, 42% in grade 8, 66% in grade 12. The same thing was done in a refresher course for nurses in 1999, and the initial measurement was 33%. The multiplication one, I'll leave that for you to read. In my own research at the master's level, I looked at grades 9, 10, and 11. I built an instrument, 50 questions. It's a very effective instrument. It has very strong validity and stuff. But what I showed was that for a high school, grade 9, 10, 11, the overall fraction performance was 38% with a standard deviation of 22%. Decimal performance was 60%. And when you mixed them, it was 39%. In effect, when the questions are mixed, it is the fractions that pull it down. It is the lowest level of performance that dictates what you get when you have a mixed question. So much as the students can handle the decimal part of it, the fraction part is the bottleneck. Calculators improved it, but they were not statistically significant. I did not force them. I did not encourage them. I simply let students choose whether or not to use their calculator. A question like 2/5 plus 0.3. This was based on the literature. I measured it at 39%. It had been used in an instrument in 1983, and it came out at 42%. When I asked about multiple meanings of a fraction, so I've mentioned part whole, there's a portion of a set. There is strictly as an operator, think of it as an action. I'm going to have something. A ratio where a ratio sometimes, if you're mixing a solution, it's how much of this and that in order to get to a liter. So it can be a little bit different. Those are four potentially distinct definitions. 22% of students acknowledged there being three or more meanings of a fraction. And as far as utility goes, that Venn diagram shows that very few students felt that fractions have utility. It's not impressive on the decimal side. But the strange part of this is the don't know. And that speaks to it not being in context. So they're being taught fraction skills, decimal skills, but it hasn't really been put into some sort of circumstance where the fraction or the decimal holds specific meaning. So for example, if you do a money question and you need 2 decimal places to support business applications, that's a pretty clear utility of the decimal, and it corresponds with money. These students didn't recognize that. A third of them didn't recognize this. And so in high school, a lot of time gets spent on putting math into context. The realities are that high school tends to emphasize improper fractions, that it does not use mixed fractions. Don't shoot the messenger. I personally think that's misguided. I think there should be mixed fractions, and it should be used to review fraction skills regularly. By the way, my research showed that between grade 9, 10, and 11, there was no increase and no decline in fraction skills. It was static. There is a general migration to proportional reasoning and things like equation solving. Ratios get a little bit, but it tends to tie to ratio or to proportional reasoning. So a map scale, for instance, would get used. But it's constrained, and the chemistry problems where you're mixing 2 solutions where a chemical reaction occurs, those sorts of things are sort of beyond what math teachers would typically do. And the remediation tends to be in terms of compensation. You don't like 3/5? Okay. Do 3 divided by 5 on a calculator. Convert it to a decimal. Now work with that. Not always, but as time permits, a teacher will gauge whether compensation strategies are better than trying to actually fix the problem. As far as compensation strategies go, focusing on the tape measure fractions that all have powers of 2 in the denominator is a serious simplification that really helps. It leads to a limited procedural knowledge, but it can get students to make progress. Similarly, baking fractions where all the denominators are small and you use unit conversions. So if you want a 24th of a cup, well, you actually convert to teaspoons or tablespoons. So a 24th of a cup, that's a third of an eighth of a cup. That's a third of 2 tablespoons. It's a third of 6 teaspoons. Well, a third of 6 teaspoons is 2 teaspoons. And so there's that conversion was relatively involved, but there are ways of structuring this so that students can have success with it. And so by changing the unit from cups to teaspoons or tablespoons, eliminates the fraction and makes it into a counting problem. Sometimes converting to decimals, which I mentioned, hands-on tools less and less because of time restrictions. And similarly, instruction on basic skills around fractions across the board. You might focus on special cases, but as far as across the board, time gets tight. It doesn't happen. What we know about colleges is that college level students have exactly the same misunderstandings and issues as elementary school students. We know that college students tend to emphasize procedural knowledge over conceptual. We know that the parts of a whole definition is a problem for 20% of college students, roughly. We know that contexts provide their own challenges. Reading a syringe is not the same as a pencil and paper question. And some medical pieces, we know that the issues they run into are substantial because medications don't come in unit quantities and you need a part of, and the circumstances create a whole different kind of question. This last point is really important. A study of 25,000 college students in the US, I believe, pointed to the questions dictating what course these students would go into fell into categories, and 69% of the students who ended up in basic math missed by one question in the fraction category. And so it's being argued that fractions are being used as a filter, and that it is causing students to end up in basic courses, whether they will ultimately need fractions or not in their program of study. And so the larger debate around this is whether or not the placement itself is corrupting the opportunities for students. So if you go to an elementary school that is not that great at teaching fractions, potentially you end up in basic math and it constrains your college courses. That's where that's coming from. And I don't have the quote on, or the citation on that, but if anybody wants it, I can find it and pull it. Nursing is a very special case. In the interests of time, I will go a little faster here, but the essence of this is you can train nurses up to a high level of proficiency, and they revert back to what they were before you trained them. They run into issues with how to choose a strategy. Calculators help, but the error tolerance isn't achieved. So if something is going to have potentially life-threatening consequences, is 90% good enough? And of course it isn't. So even if you can get a nurse to the 90% level, is that good enough? And so there's really two problems. And one is how to get them to a high level of proficiency. And the other one is how to get them to a professional level of proficiency. The context is hugely problematic. And things like unit dosing have been implemented to circumvent the issues. But they are not, there's a lot of work to still be done. The implications: fraction performance was not way better years ago. Fraction performance has been a problem basically forever. Increasingly, it's looking like there could be very fundamental problems behind it. There's a study out of Korea that comparing Korea and the US that show that in spite of very different education systems, students show exactly the same problems. And it is not culture, it is not textbooks, it is not, and it eliminates a whole bunch of things. We did see a decline in the province. If there was a decline, it was 20 years ago. As politely as I can possibly say this, get over it. And the decline was because computers got put into the math curriculum to support learning how to use technology. So if there was a decline, and key there is if, the way it's measured is a problem. The occupational focus complicates. It's important. It potentially offers strategies, but that depends on the occupation. There are fundamental systemic issues, and progress is being made, but it is very slow. And there's a series of references. Actually, what I'll do is I'll show the references here slowly. Open discussion. Actually, I'll speak to this slide first. I want to thank Derek Jennings, by the way, who's operating in the background and has been very good about making sure this all works. I'm interested in research in this area. I have not done much since my master's thesis. It's an area of interest. The opportunities are challenging inside the school system. If it's something you are interested in investigating, it might be something we should talk about. I certainly have an instrument that can measure it, that can be compared, yada, yada. I'm going to go back and show my reference lists, but I'll open it up to any discussion that you wish. Does anybody happen to know where the word vinculum comes from? And if you would like to ask a question, feel free to throw your microphone on or put your hand up. Go ahead, Julian.
So you were saying about 20 years ago is when you're seeing that perceived kind of lowering in fraction skills. That doesn't really coincide with the introduction of the metric system, does it? So
no, the introduction of the metric system was in the late 70s. And so it might have been more of an issue around the 80s. I was the first generation to use metric. And in fact, I believe I can say accurately that when I was in school, we were only ever tested in metric. So it goes back prior to that. The change in the late 90s was how to handle computers as far as the school system goes. And to the credit, you know, I always feel a bit bad for teachers that they get sideswiped over fractions. The first 30,000 computers in Ontario classrooms were brought in by teachers. They were not purchased by the school system. And so the policy side needed to come up with a way to handle technology. Slide 11. Yes, I will go there. I just have to figure out how. Go to slide 11. There you go. There's slide 11. Is that the correct slide?
Yes, that's the correct one. Thank you.
All right.
The question I asked was whether or not anybody knew whether vinculum is Latin or Greek. Sorry, go ahead, Derek.
Well, I guess, Teres, do you have one last question? Oh, your hand went away.
Me, I guess time is almost up. So I was going to continue or open that conversation about I don't really understand why the term fraction is being used right from the start, because it ends up being confusion. We have to bring in terms like proper and improper and mixed and all that. So why don't we just come up with other terms? I've come up very haphazardly with numbers between whole numbers that I use in my college classroom when students struggle with fractions. I just forget the term because it ends up being, it's not well defined. And I don't know why we continue to use it.
The language around it is a huge challenge.
Yeah.
The word denominator, numerator, who came up with those? You know, and the language really is a challenge. And then you start to say, well, you know, could we do better? And, you know, I could make a case for introducing mixed fractions before improper fractions. And I can
use
use
just call them rational numbers that can be expressed as a ratio. Done. That's what mathematicians did. And we were teaching mathematics. Why don't we use that language? Like, I'm just befuddled that we're still using that language and sticking to it and trying to turn ourselves into pretzels when I don't know if all of us agree, but obviously you agree with me. So like,
yeah, and you've got to hear Taras, in the chat. You know, there definitely are questions to be asked there, and I cannot offer you an answer. You know, this comes in very early in the elementary curriculum, and you're talking grade 5 and earlier. And as to why it's done that way, I don't know.
Right. But yeah, and I think anyway.
All right.
What's interesting about it for you and me, Taras, is on the numeracy side, you do not hear that in general usage in the public. That language all disappears. And if you go into generic settings, such as a workshop, you do not hear those terms being used. I'm fine to stick around, Derek, if we can keep this open, but if we have to close it down, we have to close it down.
All right, well, I'll maybe, what I can do is I guess I can keep it open. I'll just quickly say thank you, Tim. This definitely creates some context to the struggles that our students are facing when they're learning or relearning fractions in our classroom. Corey indicated to me that he already did his farewell, so I'll just quickly echo his words and say thank you to all of our presenters and our attendees. You know, our executive is already talking about and planning for May, so we're really excited to get that together, and hopefully we all get to see each other in person at Fern at that time. So everybody enjoy the rest of your week. If you do have, if you are on break right now, hopefully you get a chance to get caught up on your marking. And yeah, I think I can probably leave this session open. I'm just gonna stop recording and duck out myself.
Thank you, Derek. So if there are any questions and things, feel free to